here both are moving, nothing but both are conducting. So conduction will happen due to holes as well as the electrons. So here in the intrinsic semiconductor or pure semiconductor, the number of holes and the number of electrons will be same. So these are what carriers? These are the intrinsic charge carriers. You have to remember one formula in this, that is we call it as mass action law. So what is that mass action law? Not mass action movie, that is a mass action law. So what that mass action law will say is, and also here I said that some of the questions will be possible from the introduction to the topics. So that is based on the mass action law only. So what it will be means, here I said that number of holes is equals to number of electrons. Why? Because both will be conducting in the intrinsic semiconductor. Now this is exactly equals to the number of intrinsic charge carriers. Nothing but I said that in the intrinsic semiconductor, holes will be carrying the charge and also electrons also will be carrying the charge. By just moving, they will just give you a conduction. So here I said that number of holes is exactly equals to number of electrons. Those are holes or electrons, those are what here? Charge carriers. Which charge carriers? Nothing but intrinsic charge carriers. The mass action law says that the Ni square is equals to what I can write? Ni square is equals to, I am saying that here Ni is equals to Ne is equals to Nh. Nh into Ne. Can I write like that? N into N is what? N square only. Clear? So that Ni square is equals to Nh into Ne. Important formula. This is known as a mass action law. I don't know why this name came, but mass action law is the name of this law. Ni square is equals to Nh and then Ne. In this mainly in the intrinsic semiconductor, I am not doping. If I dope, I am adding which one here? If I dope with the pentavalent, what I am adding here? Extra electrons. Whenever I dope with the trivalent, I am adding the extra holes. Nothing but there it will be unbalanced. But here I am neither adding the holes nor adding the electrons. So whatever the number of holes are there, that many number of electrons will be there. These holes and the electrons are charge carriers in which type of semiconductor? Nothing but intrinsic semiconductors. So only I said this as number of intrinsic charge carriers. Now what mass action law says? Nothing but they will say that in the question they will give that number of hole electron concentration, like that they will give the problem. We will solve the problems also. So in that Ni square is equals to what I can write? Nh into Ne. However, whenever I multiply these two, I said both are equal, then what will get? N square only, that N square only this one. Ni square is equals to Nh into Ne. This is a mass action law which is there in the intrinsic semiconductor or pure semiconductor. Now whenever you come to the extrinsic semiconductor, at that time in extrinsic semiconductor we are having one is N type semiconductor as well as a P type of semiconductor. In N type semiconductor, which will be more? Which are the majority charge carriers? Electrons. So that here electrons Ne will be greater here. Ne will be much greater than Nh. And then in the P type what will be there? Nh is much greater than Ne. And here conduction will be only possible due to the electrons here. Here conduction will be there due to the which one? Holes. And conduction will be there in which band here? Conduction band. Here conduction will be there in the valence band. And also here what will be there? Donor level will be there near to the conduction band. Here acceptor level will be there near to the valence band. You understand that theory, right? Clearly? Then this is about the mass action law. Right that. In the pure semiconductor or intrinsic semiconductor, first in the introduction you write it as intrinsic semiconductor. Directly we have started the band theory, right? There you write first of all intrinsic semiconductor, band theory, next intrinsic semiconductor. Band theory, comma intrinsic semiconductor you write. In intrinsic semiconductor or pure semiconductor, last you write. Now you continue your notes. In the intrinsic semiconductor or pure semiconductor, intrinsic and pure or pure semiconductor, The conduction is possible due to holes as well as electrons. Holes as well as electrons. The next line, the hole concentration and electron concentration will be same in the intrinsic semiconductor comma in this charge carriers are holes as well as electrons. Holes as well as electrons known as intrinsic charge carriers. Ni in bracket. Ni. Underline that word, intrinsic charge carriers. Next, mass action law. Write this law here. Next, about the energy gap, very important formula, this one is important. Next, energy gap, about the energy gap we will discuss. Where is the energy gap here? Energy gap or band gap we can call between which one? Valence band and then conduction band. I said that we will divide the materials into 3 types based on this energy gap only, I said. So, whenever you take the conductors, energy gap is how much? 0, nothing will be there. Both bands will be overlapped on each other. Whenever you come to the semiconductor, the gap will be very less. Whenever the insulator, it will be more. So, here that energy gap value will be how much? That is what we will discuss here. Now, whenever the energy gap is less than or equals to 0, which materials these are? Conductors. Band gap is less than 0, nothing but overlapped. Otherwise, it is 0, nothing but just they are one on each other. So, at that time, the conduction band and valence band are overlapped. Then which type of materials here? Conductors. Then here, whenever the energy gap is less than 3 electron volts, at that time these are semiconductors. In these semiconductors, almost in 90% of the problems we will use only 2 semiconductors. These are silicon and then germanium. For the silicon, what is this energy gap? Nothing but that is 1.1 electron volt. For the germanium, that is 0.7 electron volt. Very important values. Whenever in the PN junction diode problems, whenever you solve, directly they will give that as a silicon junction diode, otherwise germanium junction diode. If you don't know this energy gap, means your answers will be wrong. So, first of all, silicon is 1.11 electron volt, germanium is 0.7 electron volt. And then next one is, whenever the energy gap is greater than 3 electron volts, which type of materials then? Insulators. Band gap is very less, overlapped. Conductors, it is little bit in between 3 and then 0, at that time those are semiconductors. It is more than 3, nothing but there is more gap between the valence band and then conduction band. So, which type of material? That is insulator. These are dead important, very important. Copy that note point. Finished? And I'll tell you one trick to not confuse these values. Alphabet G number is how much? Alphabet G 7 yes sir. A B C D E F G correct 7 number is 7, so that only 0.7 electron volt. Finished. In silicon I is there, I is same like 1 only, so that 1.1 is the silicon value and then germanium value. Clear? Remember like that. See, whoever are saying wow, I am giving you sharpa that in the exam you will do that mistake only. Not sharpa also, I am sure about that you will do that mistake only in the weekend exam. Baba ki baba. It's clear? Then conductivity. ನೀವು ತದಾಸ್ತು ಅಂದರೂ ಮಧ್ಯಾಹ್ನ ಕೀ ಬಂತು. ಚೆನ್ನಾಗ ಮತ್ತೆ ಹೋಗಿ ಪ್ರೇಯರ್ ಮಾಡಿದ್ದೀನಿ ಅಲ್ಲಿ ಕುತ್ಕೊಂಡು ಆಫೀಸ್ ರೂಮಲ್ಲಿ. ನಿಮ್ಮ ಮಹಿಮಾ ಎಲ್ಲ. Conductivity. What is the conductivity? Generally, what is the conductivity? What is that? Definition ಎಲ್ಲ ಬೇಡಮ್ಮ, ಲಾಂಗ್ ಟರ್ಮಲ್ಲಿ ಏನು ಅವಶ್ಯಕತೆ ಇಲ್ಲ ಡೆಫಿನೇಷನ್ಗೆ. ಫಾರ್ಮುಲಾ ಹೇಳ್ರಿ. ಕಂಡಕ್ಟಿವಿಟಿ ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ರೆಸಿಸ್ಟಿವಿಟಿ 1/ρ. ಸಿಗ್ಮಾ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 1/ρ and then that is a conductivity sigma is equals to 1/ρ. Conductance G is equals to 1/r. We will discuss that. So that is what in the current electricity we have discussed in the conductors topic. Then now conductivity in semiconductors. In that first of all pure semiconductor I will take. What is the pure semiconductor means? Intrinsic semiconductor. So in the intrinsic semiconductor I said that conduction will happen due to which one here? Only electrons or only holes or there is both? Both, due to the electrons and holes. Now here the conduction is happening due to the electrons as well as the holes. Now I will take electron is E and then holes as a H. Now total current I am gaining as I here. The current is due to what you people are saying, that is due to the electrons as well as holes. So that only I is equals to I will write as IE plus IH. Yes, due to the both current is supplying here, so that only that is a total net current. Now here I is equals to in terms of drift velocity. They are drifting obviously, drifting towards one band to the another band. I is equals to what is the formula? NEAVD. Correct, that is the formula. Now whenever you see the total current I is equals to I due to the electron, remember properly here, what is the formula for us? NEAV. V is the drift velocity I will take. Due to which charge carriers here? Electrons. So that only Ne and then Ve. Area is same only. Area of the conductor will not changes. Electron charge also same only. Then plus IH. IH nothing but NEAV NH VH. You understand right what I have written here? So NEAV is a general formula for us, for the electron separately, for the hole separately. Then here what I can take common? EA common. Then what is remaining? NEVE plus NHVH. And then this is the I got. Now I want to get the voltage. How to get the voltage? V is equals to IR. So that V is equals to IR nothing but I want to get the voltage. V is equals to I into R I will write, that is REA into NEVE plus NHVH. You are understanding right what I am writing here? So now in the place of R I want to get the conductivity, means first of all I should get the resistivity. So in the place of R what I can write? Rho L by A. In terms of resistivity what is the formula? R is equals to rho L by A. So that rho L by A EA into NEVE plus NHVH. Then AA gets cancelled here. Then this is the V. I want to get the electric field. What is the electric field formula? V is there, L is there. So that what I can write? V by L. So that V by L is equals to rho E into NEVE plus NHVH. This is what I got up to the electric field. Now I want to get the entire answer in terms of mobility. What I can do? What is the mobility formula? Do you remember that? Mu is equals to Vd by E, drift velocity by electric field we got. That is the mobility mu I said. Do you remember that? Mu is equals to Vd by E. Now here I got the V by L. V by L is nothing but simply E, that is rho E Ne Ve plus Nh Vh. Then now I want to get the mobility, nothing but first of all I will take the resistivity this side. So what it will be there? I by 1 by rho is equals to E into what I do, nothing but here Ne Ve by E plus Nh Vh by E. Is there any problem in that? I send E this side and then I taken the rho this side. Then 1 by rho is what? What is the 1 by rho? Sigma conductivity. So that sigma is equals to E into Ne. What is the velocity by electric field? Mobility, right? Mu of which one? Electrons, and then Nh mu of the holes. This is the formula, very very important. This is the conductivity. Each and every formula is important as per the given question. You have to, for example, they are asking the resistivity, then you have to use this formula. Otherwise they are asking the electric field, you have to use this formula. They are asking the voltage, you have to use this formula. All the line, each line is giving one formula here for different problems. See that in this chapter all the problems will be very very easy. You should not leave one problem also. There is no tricky questions, nothing will be there. Everything is straight away. Any trick is there, nothing but in the Boolean algebra we will get some of the tricks, that's it. Here whatever the introduction topics, all are very easy and then just directly based on the formulas only. So each and every line form is here total current they are asking, nothing but you have to use this one. Clear? You have to use different formulas as per the given question here. So now listen, in the intrinsic semiconductor what happens, nothing but total current is due to the electrons as well as the holes. So only I is equals to IE plus IH I have written here. Then here I is equals to IE. The electrons and then holes are drifting here. Drifting from the valence band to the conduction band and then valence band to the other bands also. So they are drifting, nothing but they will have which velocity here? Drift velocity. So that only I have written that as NEA into drift velocity. Everything about the electrons, so only I have written Ne and then Ve. However charge is same only for the hole and then electron, and also area of the conductor also same only. In the one silicon conductor only we are discussing here. Then next one is about the holes, I have written the same thing. I have taken EA common, I have got this one for the total current. Now I want to get the voltage, means simply voltage is equals to what? Current into resistance only. So I just multiplied with R for the entire equation here. Then in the place of R I have written rho L by A, because I want to get the conductivity, means first I have to get the resistivity. So rho L by A gets cancelled, whatever remaining is there that we got here. Then after that I am sending the L down here. V by L is equals to what we get? Electric field E. Pavitra, are you okay? Idara class alle? V by L is equals to rho E into NEVE plus NHVH. Now V by L is the electric field and then I am sending the rho down and then electric field here down. Then 1 by rho nothing but conductivity. Drift velocity by electric field is what? Mobility, and then drift velocity the hold by the electric field also mobility of the holes, mobility of the electrons separately we got. Clear? This is about the intrinsic semiconductor, pure semiconductor. If I talk about the extrinsic semiconductor, at that time in the n-type semiconductor who are carrying the charge here? Current is due to only which one? Electrons only. So for the n-type semiconductor I can take that I is equals to only IE, only due to the electrons only. For the p-type semiconductor I is equals to only IH. Then I is equals to here what I can write? NEA, I am sorry E here again, electrons, and then NEAVE. Correct? Only first half we will get, that's it. Everything is just half only we will get. So now tell me directly what is the resistivity here? 1 by rho is equals to what we will get? E, Ne, and then mu E, mobility mu E. Then this is nothing but the conductance only, sigma is equals to, this is what you will get. For which type of semiconductor? This is n-type semiconductor. For the p-type semiconductor I will get I is equals to NHEAVH. and then sigma is equals to 1 by rho is equals to E NH and then mu H. And now I want to get the current density. What is the current density means? Do you remember the formula? I by A. J is equals to what is the formula? I by A. Now from this tell me the J value. J is equals to what I can say? I by A nothing but NEEV. And then here J is NHEVH. That is the current density in N-type semiconductor as well as a P-type semiconductor. So next one is extrinsic in that N-type as well as P-type. Right, directly. First of all, pure intrinsic semiconductor, first one. Write that conduction is due to both electrons and holes. Conduction is due to both electrons and holes. Copy everything. Each and every step is a formula. That's it. I am saying again and again the same words only. ಎಲ್ಲಿ ಹೋಗಿದ್ದಾನೆ ಯತೀಶು? ಮನೆಗೆ ಹೋಗಿದ್ದೀರಾ? ಅವರು ಅದನ್ನ ಇಬ್ಬರು ಸೇರಿ ಹೋಗಿದ್ದೀರಾ ಏನು? ಇಬ್ಬರು ಒಂದೇ ಸರಿ ಹೋಗಿದ್ದೀರಾ? ಫಿನಿಶ್ಡಾ? ಅರೆ ಮನೋಜು ಇದೆ, ಈ ಪಕ್ಕ ರಬ್ ಮಾಡು ಫಸ್ಟ್. ಓನ್ಲಿ ಈ ಪಕ್ಕನೇ. ಸಾಕು ಬಿಡು. ಫಿನಿಶ್ಡಾ? ಏನು ಯುವರಾಜ ಎಂತ ಮಾಡ್ತಾಯಿದ್ದೀರಾ? ಹೋಗಿ ಫೇಸ್ ವಾಶ್ ಮಾಡ್ಕೊಂಡು ಬಾ. ಇಲ್ಲ ಚಾಕ್ಲೇಟ್ ತಿಂತಾಯಿದ್ದೀರಾ ಆಲ್ರೆಡಿ? Right, next very important table about the intrinsic and then extrinsic semiconductor. Right, here I have taken intrinsic as well as extrinsic semiconductor. First of all, I have taken the bands, energy bands here. This one is a valence band I will take, and then this is a conduction band I will take. Now here what happens? Whenever the conduction process is going on, at that time what happens in the valence band and then conduction band? What happens? Electrons from where to where they will jump? Valence band to conduction band they will jump. So that electron is jumping, so here like this, and so on like that. Now here, whenever you see the semiconductor, the structure of the semiconductor is like this. Number of holes and then number of electrons all will be equal in this. And also, whenever you see the current due to what? Intrinsic semiconductor, holes and electrons, due to both electrons as well as holes. Then here number of electrons and then number of holes are equal or not equal? Equal to each other. That is equals to how much? Ni. What is the Ni here? Intrinsic charge carriers. Okay, intrinsic charge carriers. Ni square is equals to how much you will get? Ne and then Nh. Now I is equals to what will get here? Total I is equals to IE plus IH. The whole current plus electron current you will get. Then this one is entirely neutral. Why? Because we are having equal number of holes and then electrons. By this only we can say that Ne is equals to Nh, nothing but this is electrically neutral. Then after that here I is equals to what is the formula we got? I think Ea into what is that we got? NeVe plus NhVH. This is what we will get. After that, if you want the conductivity also, I can write that conductivity sigma is equals to what is the formula we got? E into Ne into mu E plus Nh into mu H. Okay, that is about the conductivity of the intrinsic semiconductor. This is about the entirely intrinsic semiconductor. Next, whenever you come to the extrinsic semiconductor, in that N type is separate and then P type is separate. In that, first of all, whenever you see the energy levels, energy bands, if you see, this is a valence band and then conduction band. What happens here? Electrons moves from which level to which level actually? Donor level to the conduction band. So that this is the donor level I will take. From that electrons will jump. They will leave the hole or this does not leave? Does not leave the hole, and then meanwhile the electrons will be jumping here. They will leave the holes. That is about the N-type semiconductor. This is the donor level. This is the conduction band. This is the valence band. Now, whenever you see the structure of the semiconductor inside, at that time what happens? Nothing but here first of all holes will be there. Positive ions we can call it as. Positive ions are there. For each positive ion, there will be one associated electron will be there like this. And also this is a N-type semiconductor, which will be extra here. Electrons will be extra, so that they will be there extra here. That's it. Understand, right? These are the positive ions. For the positive ions, the electrons will be there, and as well as this is a N type of semiconductor. In that electrons are majority, so that only more number of electrons are there here. Then next one is third case is current due to what here? Nide marta idra ellaru electrons only, right? Current due to the electrons. Ellaru brahmanandam agi bittidro enoni electrons. Then here what happens? Number of electrons greater than number of holes. ಮತ್ತೆ I is equals to just IE only. Then this is also electrically neutral. Why it is electrically neutral means you don't think that this is greater, right? Why she is saying like that? First of all, listen, why it is electrically neutral? Nothing but we have added which impurity here? Pentavalent. That is arsenic we have added. That is electrically neutral actually. In that the number of holes and the number of electrons will be equal. So only this is also electrically neutral. You don't do much PhD in that, you just remember that. That's it. Electrically neutral. Then I is equals to, what is the formula for us? I is equals to EA into NE and then VE. Then conductivity sigma is equals to E into NE mu E. That is the conductivity. Next one is about the P type of semiconductor. In that I will write again, I will just draw the valence band and then conduction band. Now you have to tell me what happens in that. Where the conduction will happen in this valence band, so that acceptor level will be there. From the valence band to the acceptor level, electrons will be jumping. They will leave all the holes here. So some of the electrons will be even jumping into the conduction band, so that very minor number of electrons will be there. Due to that also conduction will happen. But what happens? Nothing but the whole conduction is more as compared to the electron conduction here. So that here this one is nothing but due to the electrons, excited electrons are jumping from valence band to the conduction band. Even above this they are going. Then next one is, whenever you draw the structure of that semiconductor, that will be negative ions will be there. For that negative ions, what will be there? Associated holes will be there. For each and every negative ion, associated holes will be there. And also what will be extra here? Holes are extra, so that I will get extra holes here like this. That is about the structure of the P type of semiconductor. Then after that current is due to which one? Holes. Majorly, this is just majorly. Both will be there, but majority charge carriers are holes. Even due to the electrons also conduction will happen here. Which electrons those are? Electrons present in the conduction band. Okay, excited electrons I can say. So this is also majorly due to the whole electrons here. Then here what I can write? NH is much greater than NE. I is due to only IH. And then this is also neutral only. Why? Because the indium also electrically neutral. So that this is also neutral. And then here I is equals to, what will get? IH is equals to EANH and then VH. Then sigma H is equals to, what will get? ENH and then mu H. Write everything. ವಾಟರ್ ಕುಡಿತಾ ಇದ್ದೀರಾ ಎಲ್ಲರೂ? ಡ್ರಿಂಕ್ ವಾಟರ್, ಮೋರ್ ವಾಟರ್. ಬೇಕಾ ಯಾರಿಗನ್ನ? ಇಲ್ಲ ಅಂದರೆ ತಗೋರಿ. Right, we will solve the problems. Finish it fast. This is here acceptor level. ಹಲೋ ಮೇಡಮ್.
ಮೇಡಮ್ ಅದೇ ಕ್ವಶನ್ ಪೇಪರ್ ಆಲ್ಟರ್ನೇಟಿವ್ ಕರೆಂಟ್ ಏನಾರು ಹಾಕ್ಬೇಕಾ ಹಿಂಗೆ ಅಂತ ಕೇಳಕ್ಕೆ ಮಾಡಿದೆ.
ಯಾವುದು?
ನೀಟ್ ಲಾಂಗ್ ಟರ್ಮಿಗೆ ಅಂದರೆ ನೀವು ಯು ಎಸ್ ಎಸ್ ಯಾವ್ದಾರು ಹಾಕ್ಬೇಕು ಏನೋ ಅಂತ.
ಅದಾ, ನಾನು ಹೇಳ್ತೀನಿ. ನಾನು ಸ್ವಲ್ಪ ಕ್ಲಾಸಲ್ಲಿದ್ದೀನಿ.
ಹೌದಾ?
ನಾನು ಫೋನ್ ಮಾಡ್ತೀನಿ.
ಇದ್ದಿಲ್ಲ ಹೊರಗಿದ್ರೆ
ಸರಿ ಸರಿ.
ಸರಿ ನೀವೇ ಮಾಡಿ ಮೇಡಮ್ ಹಾಗಾದ್ರೆ.
ನಾನು ಮಾಡ್ತೀನಿ. ಆಯಿತಾ? ಮೇಕ್ ಇಟ್ ಫಾಸ್ಟ್. ಹಲೋ ತರುಣ್ ಮಾಸ್ಟರ್, ಇದರಾ ಕ್ಲಾಸಲ್ಲಿ? ಕಂಟ್ರೋಲ್ ಯುವರ್ ಸೆಲ್ಫ್, ಇಟ್ಸ್ ಓಕೆ, ಇಟ್ ವಿಲ್ ಹ್ಯಾಪನ್ ಎವ್ರಿ ಡೇ. ಹೋಗು, ವಾಶ್ರೂಮ್ ಕರಿತಾ ಇದೆ, ಹೋಗಿ ಬಾ. ಫಿನಿಶ್ಡಾ? ಮೇಕ್ ಇಟ್ ಫಾಸ್ಟ್. Next problem, a p-type semiconductor has ಏನಾಯ್ತು, ಯಾಕೆ ಅಷ್ಟು ಬಾಧ? ಹುಷಾರಿಲ್ಲ? ಏನಾಯಿತು? ಡೈಲಿ ಹುಷಾರಿಲ್ಲಲ್ಲ ನಿಮಗೆ, ಏನು ಮಾಡ್ತಿರೋ ಮತ್ತೆ ನೀವು ಗೌತಮ್ ಇಬ್ಬರು? a p-type semiconductor has acceptor level A p-type semiconductor has acceptor level 50 milli electron volt. 50 milli electron volt. Nothing but the energy of the acceptor level they are saying. 50 milli electron volt above the valence band. Above the valence band. Then find maximum wavelength of light. Find maximum wavelength of light that can create a hole. Read the question, understand that, which you people already solved in the DL nature, the same problem only again. Repeat करना फिर. Find maximum wavelength of light that can create a hole. That can create a hole. ఎంత? 24 point? Wrong. Your answer is 2.47 into 10 power plus 5. -5, sure. -5. -5 meters. 10 power plus 5 Armstrongs. Understanding what I am saying? Your answer is correct only. You should know the units first of all. You have done in the terms of what? Armstrongs you have done. You might be taken that as the acceptor level, energy level is how much they are saying? 50 milli electron volt. That is the energy, very smaller energy is there. Now what they are saying nothing but what is the light which is released, the wavelength whenever to create the hole. To create the hole nothing but what happening here? How the hole is created? Whenever the electron is jumping from the acceptor level to the acceptor level nothing but valence band to the acceptor level. Here what happens means, here this one is the example for that. Now here in the valence band we are having the number of electrons before. Then what happening, whenever I raise the temperature, then what happens, electrons will jump from the valence band to the acceptor level. So how much energy is needed? They are saying 50 milli electron volt is energy needed. Now whenever this electron is jumping from here to here, it will release the energy. Whenever the energy is released nothing but that energy will be in the form of light that will have some wavelength. This is the theory of that question first of all. You should think this much. Already you have done dual nature, so only you got the answer very easily. But if not, you have to think this much of theory behind that. So here they are saying acceptor level energy is given. So from the valence band to the acceptor level, electron will jump. How much energy it has to overcome? Nothing but 50 milli electron volt energy it has to overcome. Why? Because this much of band gap is there. That band gap is how much? 50 milli electron volt. Whenever the electron is jumping from the valence band to the whatever the acceptor level, at that time the energy will be released. The energy will be released in the form of light. That light will have obviously some wavelength. That wavelength only you have to find out. So already you know that E is equals to what is the formula for us? Hc by lambda. Now instead of multiplying the Planck's constant and then 3 and all, you take everything in the Armstrongs. So why? Because they have given the energy in terms of what? Electron volt only. So that 50 milli nothing but 10 power minus 3 electron volt is equals to Hc value in terms of electron volts. What is that? 12400 electron volt, that divided by lambda we will get in terms of what? Armstrongs. That is very very important. Lambda will be in the Armstrongs only. So that lambda in the Armstrongs. This is what our formula we got. Then after that you just do everything here. Lambda is equals to 12400 by 50 into 10 power minus 2. 5 into 10 power minus 2 we will get. Then this will be how many times? Approximately 25 times. And then this is going up nothing but how much will get? 25 into 10 power plus 4. What will get here? Armstrongs or meters? Armstrongs will get. So that this is the Armstrongs. Otherwise I can say this one as 25 into 10 power minus 6 meters also. Anything is correct only. Clear? This is the answer you might be get. You might be get that as 2.5 into 10 power 5 Armstrongs. Write that units properly. Then next problem. A germanium specimen is doped with aluminum. Germanium is doped with aluminum. The concentration of acceptor atoms is acceptor atoms nothing but which are they have given? Acceptors. Who is acceptors? Holes are acceptors, electrons are donors. Acceptor atoms in bracket you write as holes. 10 power 21 atoms per meter cube. Always they will say per volume only. Okay na? The number of, here we have taken NH nothing but the NH is the number of holes per volume, number of electrons per volume, number of intrinsic charge carriers per volume. Okay na? So 10 power 21 atoms per meter cube. Given that the intrinsic concentration means what they have given? Ni. Ni, intrinsic concentration of electron hole pairs is 10 power 19 per meter cube. साइफ लिखो पहले, सो जा रहा ना नहीं. The intrinsic concentration of electron hole pair is 10 power 19 per meter cube. And then find the concentration of electrons in the specimen. Find the concentration of electrons in the specimen. Get the answer. You should not take even this much time also. You should 10 power? Yes, very good. If you are taking 10 seconds also, you are wasting the time only. Yes, yes. Next answer. ಮಾಡ್ತಾ ಇದ್ವಾ? Why this much time for that? 10 power 17. How many of you got that? Raise your hands. Yes, good. What about the boys? Nobody got boys, only one boy. What's the answer? Mass action law. Ayyo. Look at the problem. A germanium specimen is doped with aluminum, whatever it might be. The concentration of acceptors, nothing but what they have given, a number of holes. Number of holes is equals to 10 power 21. Then given that intrinsic concentration of electron hole pair, how much they are giving? Ni is equals to 10 power 19. Then after that you have to find out the concentration of electron. That is how much? Ne you have to find out. From the mass action law, what I can say? Ni square is equals to Ne and then Nh. Then Ne is equals to Ni square by Nh. That's it. 10 power 19 whole square, nothing but 10 power 38 by 10 power 19. How much will be remaining? 10 power 17 is remaining. That's it. 10 power 17 per meter cube. That's the answer. ಎಷ್ಟಪ್ಪ? 21 ಆಗುತ್ತೇನಾ? ಹಾಂ, 10 ಪವರ್ ಮೈನಸ್ 19 ಬರೆದು ಅದರ ಅಭ್ಯಾಸ ಆಗಿದೆ ಅಮ್ಮ ನಮಗೆ. ಏನು ಮಾಡಬೇಕು? That's the answer you got. Then a semiconductor has equal electron hole concentration. Means again what they are giving? Equal electron hole concentration means what they are giving? Ni they are giving. A semiconductor has equal electron hole concentration 6 into 10 power 8 per meter cube. 6 into 10 power 8 per meter cube. On doping with certain impurity, the electron concentration increases to 9 into 10 power 12 per meter cube. Then in that first question, identify the new semiconductor. Obtained after doping. Nothing but you have to identify that is p-type semiconductor or n-type semiconductor. Yes, next question in that, calculate new hole concentration. Which type of semiconductor? Which are increasing here? Electrons are increasing, nothing but n-type semiconductor. First question is finished. Next one is NH you find. How much you will get? 4 into 10 power 4. Very good. 4 amma. Rajeshwari akka. Handicap. 4 into 10 power 4. ಇದರಲ್ಲಿ ಏನು ರಿಸರ್ವೇಷನ್ ಇಲ್ಲಮ್ಮ ನಿಮಗೆ. 4 into 10 power 4 per meter cube. NH is equals to Ni square by Ne. Clear? You got the answer, right? Yes. Next problem. Next one. What will be the conductivity of, what will be the conductivity? You have to get the conductivity formula. What is that? Sigma is equals to E into Ne mu E plus Nh mu H. Then what will be the conductivity of pure silicon crystal? Conductivity of pure silicon crystal at 300 Kelvin. At 300 Kelvin temperature. See that they have given as, listen one second, again they have given here, they did not mention that there is intrinsica extrinsica, but one word they mentioned that. What is that? Pure silicon crystal. So that is obviously which intrinsic, in that which will be carriers? Electrons as well as holes. You will get the entire formula. Okay. Then if electron hole pairs per centimeter cube, if electron hole pairs per centimeter cube is 1.072 into 10 power 10. 1.072 into 10 power 10 at this temperature, and mobilities are mu h is equals to 1350 centimeter square per volt second, and then mu E is equals to 480 centimeter square per volt second. Get the answer. Conductivity we get in terms of centimeter only, no need to convert into meters again. Directly conductivity formula,